Hi everyone, and welcome to the 14th webinar in the AWC3's webinar series about watercourse crossings. My name is Daniel Monaco and I'll be acting as your host for the webinar today. Before getting into it, I just want to give a brief introduction to AWC3 in case this is the first webinar you're attending in the series. So AWC3 is the Alberta Watercourse Crossing Collaborative. It's a not-for-profit organization whose primary objective is to facilitate information transfer around the issues of watercourse crossings in Alberta and their impact on native fish species. So that's what this webinar series is all about, is sharing information from subject matter experts and trying to get that information out to as many people as possible. Since we've received some questions about this, I want to let everybody know that this webinar can be used for continuing competency credits for professional associations. So it counts for half an hour of credit and has been approved by most of the major professional associations. So if that is something you're hoping to take advantage of, please make sure to keep all of your receipts and your registration confirmation email. And if you have any questions about this, you can email us at info@awccc.ca. So today's webinar is about ecological best management practices that are required to conduct watercourse crossing repair, replacement, and restoration. And we have Bruce Nielsen from Woodlands North here with us as a presenter. So to give a bit of background on today's presenter, Bruce is a registered professional forester in Alberta and has been for 21 years. His focus of work has been on the inventory and restoration of boreal habitats, including work with caribou, but primarily with fish and water. College in the late 80s and took fish and wildlife as well as conservation and restoration. He then worked in northern BC for a few years and attended UNBC when it first opened its doors, and he obtained a degree in forestry and a minor in fisheries. So he then returned to Alberta in 1997, and after working for a few different companies in consulting, he started Woodlands North and has been doing that for about 21 years. So before passing things off to Bruce, I just want to let everybody know, if you have questions throughout the presentation, you can submit those through the GoToWebinar program in the toolbar on the right-hand side of your screen. I'll be compiling those questions and we'll get to them after the presentation is complete. So we'll have about 25 to 30 minutes of presentation, followed by about 30 minutes of a Q&A. At that point, we'll also have Mike Hunka with us from AER as a panelist, so he'll also be able to answer some questions if Bruce isn't able to. I would also like to ask that any of the questions being asked pertain directly to the topic of the presentation so that our presenter and panelists can answer those to the best of their ability. So without further ado, I will pass things off to Bruce.
Great, thank you, Daniel. So as Daniel mentioned, I run a small consulting firm in Edmonton. We have a long-serving white court office as well. And my coordinates are on the screen if anybody needs to get a hold of me, and they'll be at the end of the presentation as well. So I'll give you a brief history of why we are here first, and then I'll touch on the restoration of site selection and some of the things to consider. But I'll mostly focus on number 3, 4, and 5, the assessment, the planning, and implementing the plan. And we'll close with some comments on monitoring. So first I'll get to some notes about the presentation and bigger questions out of the way. So this presentation is primarily about replacing a failing culvert crossing or removing a culvert crossing and installing a new creek bed. And I may hazard some water flow knowledge from experience, but I'm not an engineer in any capacity, and I can state to their importance in this type of work. So this isn't a boreal example, I apologize for that. And the rationale is that the majority of the problem is in the foothills and the terrain-driven landscapes that these crossings are on. And there's really no pure biology here either, rather functional ecology, as I like to refer to it. So first question that usually comes up is, where do you find this information in the province? The BMPs for the province, they're written and stated. They're fairly broad and they leave room for interpretation, which is a good thing, because as a professional, you get to use your judgment and practice on a lot of these aspects. But they are written and stated. And watercourse crossings itself, it's a well-documented field of practice. and there's lots of good evidence-based learnings from other jurisdictions. BC is a fantastic example, as well as the USDA, such as the Minnesota Department of Natural Resources and the Rocky Mountain Research Station, all produce quality information about watercourse crossing management. So the BMPs, they are written and they're stated, and you can find them. This slide is small and you can go find it on your own. They are evolving and they will change soon. So as Mike Hunka mentioned in his presentation, the new master schedule of standards and conditions is coming out soon. So we can look forward to those. So essentially, let's get started. So how did we get here? So the reason fishery is in this state is because the crossings we are dealing with are failing. And while they may have been put in correctly at the time, they have generally been poorly maintained and they're not meant to be long-term. The results are that they become hanging, broken, and barriers to fish passage, and they interrupt or stop ecological flow. Moving forward, we have to utilize different crossing types. We have to install new crossings better, and we have to conduct regular maintenance. And culverts too, they're not going away. So a brief culvert hydrology lesson. Again, not an engineer here, but creeks are dynamic and constantly move, while the roads we make, they stay in place. So the watercourse crossing that we develop, it pins the dynamic creek in place, and in time, this becomes a point of failure. So as Mike Bender pointed out in his presentation, the crossing location serves as a point where downstream movement of sediment becomes deposited above the crossing at the intake end, and the increased velocity of water through the crossing erodes on the output side. So this overall process buries the intake at the end of the pipe and it perches the output end. So if you think of the creek as a ribbon or a rope, you can think of a poorly installed or maintained crossing as a pair of scissors that cuts that rope. And while this is happening to creeks and crossings, the traffic for the most part keeps moving above, and we don't get out and we don't look down to see what's going on. So this next photo, it's a crossing in west central Alberta that we replaced, and it's a 1,000-millimeter pipe with an intake 22 feet buried in silt, about 18 years of buildup, and this is an Arctic grayling creek. So moving forward, as long as we don't install crossings in the same manner that got us here in the first place, we'll improve the situation and we'll change the trajectory that the provincial fishery FSI has been on. In essence, we have to change the way we design and install, inspect, and maintain these culverts or these crossings, culverts or not. So a little bit about site selection. So regardless of the reason for the watercourse crossing fix, ecological best management practices have to be employed for all the crossing works. So emergency works does not mean no mitigative measures. So in an emergency repair, you often don't have time and space for all the planning of all the eventualities, but the care given to fishery and water management has to be the same, and the QACE or the ecologists need to be involved to help this aspect be properly managed. Also, you'll have less interaction or engagement with the regulators because of the nature of the event, but keep them posted on the process used and the results from the works that you do. And just because it's an emergency repair doesn't mean you cannot add some functional ecology to the product with a few good measures. And this is what we're going to talk about, such as riparian restoration and channel roughness. So if it's a planned restoration, just a note here, ensure you're selecting the site with the most ecological beneficial repairs. You want to aim to work on high priority watersheds, high volume streams, and projects that are going to connect lost or isolated habitat and will lead to contiguous stream reaches. Try to ensure that there are no other anthropogenic barriers downstream. If you're directed to restore a site, you should try to confirm it's the best use of your resources. And this could be tricky, and it could require a lot of collaborative efforts with your regulator and even with your neighbors, perhaps. But at the time of the emergency facing our provincial FSI, there really is no value in wasting watercourse crossing dollars on a site of low value. So if we're going to spend money, we want to make sure it's the best value crossing. So this is where we'll start to spend time. We'll start with site assessments. So now you're going to step into the creek, and I trust that everybody knows the equipment and gear that you're going to need to do this. The very first thing you have to be aware of, and this is a new best management practice, is you must decontaminate for whirling disease. So if you have been in or around any of these affected watersheds and watercourses, this will be a stated condition of works coming soon in the updated master schedule. Check the map online for the decontamination zone. If any of your gear or machinery has been in them, it has to be cleaned and decontaminated. And this includes your contractors and their machines and their gear, their rubber boots, everything, hip waders. Make sure everything is decontaminated, dried off, washed off. And as Albertans, well, Canadians and the world, we're getting really good at decontaminating and understanding the spread of what an unwanted disease can do. And whirling disease has the potential to do vast damage to our native trout fishery. So you need to plan your visit to make sure it's efficient and comprehensive. Make sure you collect all the crossing data, stream reach data, habitat criteria assessments, and other information to support all the regulatory and planning work. Much of this is qualitative and it can be subjective, so take some photographs. I recommend doing a grade survey at this time through the crossing site. Determines your crossing depth and your creek channel rebuild depth. It will touch on that in a minute or two. Do an assessment of the stream's habitat features, as this is what you want to recreate. Determine the ratio of pool, riffle, and run, that the approximate sequence of what should be at the crossing location you are fixing. Should the area become a pool, or is it in the middle of the long run? These are questions you'll have to answer. And technology is great. If you can get a drone shot or an entire series to project the area into a 3D point cloud, life is much easier. And also at this time, it's never too early to meet on site with other watercourse crossing team members. Everybody within the job has their own agenda to fulfill and to care for. So starting to cross-pollinate ideas early makes the job go easier. And another technology plug here about drones. I can't emphasize how much of one good photograph and the perspective it gives to the crossing that you wouldn't get otherwise. Every group of the watercourse crossing construction team will benefit from a good photo. Ian Sharp gave a really good presentation on this, on getting very techie with drone stuff, but even one simple photo can go a long ways. So you've collected your site data, and now you're going to make your site plan. You need to share it with the client and regulator cohorts and get some feedback. So now you develop your plan, or your works, as I like to call it, and how this will unfold. So this is what's been missing from watercourse crossing construction jobs for too long. We need to start putting more thought and energy into returning ecological function quickly to watercourse crossings. And when I say quickly, it's a relative term, because what we can do in a day with a 320 excavator could take Mother Nature 25 years or more to recruit naturally. It's an awesome and rewarding task, and you get to design how you will maximize the ecological return to the construction site. Our objective here is to improve the stream's ecology. That's a best management practice. Stream ecology can be broadly divided into biotic and abiotic factors. You have a lot of control over the abiotic factors during the construction process. So you have to maximize this potential and use the site and the process to recruit ecological features or attributes. At this planning stage, you're able to artificially recruit natural features that would take the stream decades to do under natural processes. So knowing full well your stream restoration efforts are going to naturally evolve and move once you complete your task. You can immediately negate any good work or the best of intentions by not managing the key factors you have direct control over, such as flow and substrate. If you manage flow and substrate outcomes properly during construction, and you supplement the terrain work you are completing with heavy equipment with additional habitat features, you can address nearly all of the key abiotic habitat features that drive a creek's ecological process, such as light, temperature, and chemistry. So chemistry, I'm not a biologist here, but if you incorporate these attainable abiotic factors, the other biotic factors that have been excluded or reduced at a failing watercourse crossing site will return to a natural state over time. So first off, or at least very early in the process, conduct a survey. You want to do this early, prior to any construction works. You establish benchmarks in the creek, make sure they remain undisturbed. Take 4 key points that'll determine elevations to build a new creek channel or at a depth at which to bed the new crossing. You want to have these points well upstream of predisposition, point number 1. Point number 2 is at the culvert intake. Point 3 would be at the output. And your final point is at first riffle, or sort of where the natural stream bed starts to resume to its natural state. So if you don't know how to do this, it's well worth digging up a YouTube video on how to do a simple survey. And I recommend doing 2 surveys. One is your transit survey, which can take as little as an hour. This determines your elevations, the key points, and your final grades. But you also want to do a stream reach survey, and this is qualitative. So you get a good understanding of what type of channel and reach delineations you're trying to mimic or recreate. One stream reach is generally a series of repetitive habitat features, a pool, riffle, run. That sort of equates to one reach. And a reach can be 20 meters or it can be 200 meters long. It's highly variable. We're talking small permanent streams here approximately. And where does your crossing location fit into this picture? It's important because if you're at the beginning, if you are beginning at the end of a run and you install another run, your watercourse will have to auto correct in time. But you can prevent this from happening by stopping that. Again, all of your work is temporary because the creek is going to move. Planning to build a foundation. If you're installing a pipe, then you're building a proper flat bed of crush that's embedded well below the channel depth you've calculated. But if you're building a creek, you'll need to do some planning. So perhaps there is a stream foundation already there, but perhaps it was removed during installation 10, 20, or 30 years ago. This is most often the case and very common. And if it is, you need to recreate it. Planning your foundation, you need to let your owners buy in or understand how to do this properly because it requires material. You want to move this material in layers. Biggest material in first, second biggest second, smallest on top, and a smattering of other attributes to put on top of that. Plan this for the entire length and width of the crossing that you're dealing with. And you want to add habitat features. Plan the macro habitat features spatially. This is the large stuff. Where to put large rock in relation to one another to provide resting cover and channel roughness. Plan the actual creek location spatially as well. Straight or curved. Any design that is off of linear is going to increase the roughness of the stream channel and can benefit all aspects of the natural development of the stream. So what is channel roughness? Essentially, smooth is bad. Smooth channels lack cover. They speed up water velocity. High water velocity increases scouring and erosion, and it impedes upstream movement of organisms. Channel roughness is exactly like it sounds. You want to make the new creek channel or the inside of a culvert rough, bumpy, and angular. It's accomplished with installing imported materials such as rocks, varying sizes. Angular rock is better than round as it gets tied into the surrounding quicker. And angular is rougher just by definition. Baffles in large pipes are a form of engineered roughness. They're expensive and they can be cumbersome, but in small culverts, when they're needed 1,500 mils or less, it's difficult to move any material into a pipe. And non-linear channel locations are rougher than straight ones. So channel roughness can and should also be accomplished with wood. So wood is good, and it never gets used. I rarely see it being used, and it's dramatically missing from channel restoration. So woody debris, or LOD, large overhead debris, it's the second part of habitat features that's going to aid in increasing channel roughness. Woody debris in the creek adds nutrients, organisms, regulates temperature, provides cover, it adds primary production, and it increases roughness. Add wood into the stream bed, directly in and under the rocks on the stream bed, and put it above the stream bed, elevated over top, limbs and all. You can see in that photo, that's a natural stream bed. You're going to need to source some wood. You do this on site or maybe via one of your neighbors, like a forest company. You do need a TFA if you're sourcing your own. If you're doing this, it can be confusing. I've gone through this numerous times. You're asking for generally a whole tree. And as folks are not used to permitting this, they generally might think you're looking for something like a Christmas tree permit, the TM66, I think it is, but it's actually a TFA, a temporary field authorization. So you put all of this together into a spatial plan that folks on the team can see and understand. So this image here, it'll get messy, but it's simply putting a hand-drawn habitat map over top of a drone photo to show the spatial layout of the habitat features to be installed. Excuse me. This incorporates the simple survey conducted at the first site visit and the alignment of the features that are in relation to the upstream and downstream natural habitat. Construction folks, machine operators, laborers, safety people, everyone who are part of a strong kickoff meeting and have a spatial plan like this to follow will do an amazing job at creating a great restored stream. So good collaborative meetings. You'll even have the pipeline guy planting willow plugs near the end of the project. And I know I sound redundant here, but a quality kickoff meeting is key to success. I emphasize this because the biologist on site often does not get the same voice as the big machinery or other values on site. The QACE who is managing this work needs space to accomplish this task effectively. All the planning you have done will unfold very quickly. It's crazy fast sometimes it goes. All the planning your creek project can unfold in a day, maybe two. And mistakes, if they get made, can be quickly and they're costly, and often they can't be undone. And note that not everybody learns at the same scale and method on the team. You need to use several approaches to get the message across what the desired end product is to look like. Thorough discussion, use a whiteboard, use pictures, walk the site with them, make sure everybody clearly understands what the desired end result is to look like. So now we get to implement the plan. These are roughly the steps you're going to go through from an ecologist perspective to get the work site ready. A strong team meeting. You need to deal with the fishery. You need to help or deal with dewatering the site. You may be assisting with the crossing structure, perhaps not. Could be a removal, a new site build, a new installation. Creek reintroduction is a key step requiring ecological input, as is monitoring once completed. So to begin, you isolate and salvage the fishery. Again, noting to wash all of your in-stream gear. A pressure washer is fantastic for this. Depending the site, you may have to start your fishery isolation several days before. I like to use layers of fencing because fence gets so jammed up with floating debris. Your furthest upstream fence, I usually make out of chicken wire with 1-inch mesh, and then you move progressively smaller to 1/2-inch mesh. Best management practices state a 1/4-inch mesh, which is crazy small, and it gets jammed up instantly. If this happens, the fence is pulled over and you may have to redo it. You'll be setting G-traps or minnow traps to passively catch fish while you're doing this and overnight. These are usually baited with cat food. Oysters works good too. And then you're going to be electroshocking at the end of this prior to the works starting and prior to dewatering. And I can't emphasize your fence maintenance is how important it is. You do not want to leave these things unattended. You may think you have a site defished, and you go upstream, downstream, and you realize that your fence is bowled over. So now you've isolated the fishery, you've caught or salvaged them and need to move them off site. So you have to make sure you've applied and completed a fishery research license or an FRL for the site. Document all your FRL data for each individual, and you'll need to upload that. I recommend a good photo system here where you simply arrange the fish and an identifier and take a photo. You really want to minimize handling of the fish, the physical hands-on handling, but also overall timing. So this means minimize time from capture to release. And ideally you have someone to process fish as they are captured and release those upstream of the works. So now the fish have been caught and the pumps are running and it's time to dewater the creek. This is your last fishery salvage. So this is where you have to make sure you get down and visually inspect all the holes for any species that could be hiding or remaining. When the water gets low, it's their nature to push into the corners, and they can be hard to find sometimes. Plus, as the water gets low, it gets very murky. So try and let it calm down, and you'll watch the edges and you'll see these small fish trying to go somewhere that they can't. And get one of those small aquarium nets, those little blue things that you catch your goldfish with. They work really well at this stage. Fish handling again. So don't be rushed and don't be shocked if you get hundreds of fish. Also, don't be shocked if you get no fish. Regardless, it takes time to process. Handle them as little as possible, hence a good photo system. Your project managers and construction managers need to give your QACE and your bio team time to handle and process the fish properly. This is a stated best management practice. Please don't rush these people. I also recommend black buckets. Just my own findings here. They work to keep fish calmer. Use lids and use tops, mesh tops if you can. Also, late season isolation and salvage is tricky. So you'll have to find a suitable hole to put these fish into. Moving them upstream of the works is not always possible. I recommend avoiding this if you can. So just a note or two about dewatering. It's not always an ecologist task, but you do have a role here to help ensure quantity and quality is maintained. This is a BMP. So there's two types, dam and pump and bypass. I recommend bypass if you can. Dam and pump is more common. Often with a bypass, you'll trench in a pipe or a trench and line it with poly. If you can, use a second existing pipe on site. In the eastern slopes, that's often the case where there's 4, 5, or 7 pipes in a roadway. Choose one of them if you can for a bypass and divert the flow through there. This photo here is the entire Pine Creek going 220 meters through the bush in one long singular roll of poly. So you can get creative at this point. But you want to dewater as small a stretch of the creek as you can, and it's also less work to do so. Managing the construction water, it's ongoing. Maintenance of downstream water quantity and quality, it's a BMP. Bell holes that are 2 or 3 big scoops at the intake and output will capture this water for you. My standard practice in a BMP for culvert work is to wash the mass of deposited sediment that is accumulated above the crossing site through the construction project area. You capture this in a bell hole below the site and you pump it off site onto the terrestrial where the sediment can settle out. You do this while you're reintroducing the stream to the construction job while the bypass is still flowing. Use a portion of that water, 20 or 30% of the creek flow, to saturate the works and move the sediment down to the outlet bell hole where it's captured and pumped onto the terrestrial. This can take many hours to do properly, but it's well worth the effort and it's the best management practice. Now you're going to reintroduce the creek. Depending on the site, this can take several hours or even longer. Don't open up the bypass or shut off the pumps and let the creek flow until the water moving through the works is running clear. And note, if there's a big plunge pool that has to refill with water, you have to run the bypass system for a long period to maintain the downstream flows while the scour pool fills up. We'll discuss vegetation clearing. This is a current best management practice to establish or reestablish a functioning riparian community. First of all, take it easy on the clearing at the beginning. Communicate this right at the kickoff to any crews who may be going to site prior to the works, and salvage what you can to use it on site afterwards. Willows and shrubs, even tree transplants can work well if they're done properly. I won't spend time here, but if you are putting in a pipe, your objective is to match or reduce stream velocity. Install it at 0%. 1 is a maximum, and embed the pipe and output at 30% or 1/3 of the diameter. That's not an AEP stated BMP, but it is good practice. DFO does state it, and the province of British Columbia exceeds it, as Michael Bender told us. This just makes sense, and this is one of the main reasons we're in the state that we're in. So now we're restoring a creek bed. Determine your channel depth and excavate to that level. If you find the old channel, great, follow it. If you can't, you have to build a new one. Define the edges, straight or curved. Try to match the natural creek if you can. Line with larger rock if you're able to. Class 3 is great. Create a stream bed of layered rocks, large angular down for the foundation. Class 2 works great for this. And you fill the top with 2 or 3 inch rounded green river rock. And then you want to add roughness, but be gentle with the roughness. Throw trees on it, root wads and all. Again, remember you're permitting. On large creek channels, you do all the work at once as you progress down the channel. You can see in these photos, all the stages are there where we have excavation of the final grade, we're importing the foundation material, and we're overtopping with our river rock and our macro features as well. So here's an example. This is a site CNRL completed in 2019 in the Swan Hills area. The left picture is a natural control upstream of the crossing area. The photo you see is the double hanging pipe. This is an Arctic grayling creek. And this is what it looked like 2 days later. This took 1.5 days from the time those pipes were removed to it looking like this. So it's very possible and quite not difficult to achieve. Again, don't overclear. Communicate the importance of mature vegetation to surveyors or operators who may want to clear the materials. This is the way people are used to doing stuff, and we have to change that way. Work with willow staking, start that early. Collect lots of clippings early on in the works and soak them in the creek. And basically you want to work with 1 meter long whips as your smallest, about the size of your thumb. And you can plant anything, willow or poplar, they'll all take when you ram them into a riparian area. I highly recommend you take this course if you're able to, or read this book if you can get your hands on it by David Polster on bioengineering. It has everything you'll need to reestablish a riparian quickly on site. So your overall objectives here: source and replace the macro features to the creek channel, or place them above and below the crossing in case of a culvert. You're managing flow and sediment to the ecological advantage of the crossing. Design what you want to see and build it, utilizing the construction equipment and managing for the key abiotic factors of sediment and flow. The microhabitat will all follow afterwards. So timing, when's the best time to do the watercourse crossing works? The COP currently outlines restricted activity periods for all species, watersheds, creeks in the province based on their based on the species needs. But regulatory best management practices and operational realities don't always coincide, and you can work closely with your QAIS and your regulator to have important jobs permitted outside of these windows. Early spring can be as bad because of peak flows and runoff. Late summer and early fall is ideal because of low flows. Late fall gets tricky as weather can change, and you can incur huge dollar increases to your project. You want to avoid some of the scenarios like the photos here. And the last thing we want to do is monitoring your work. So this is a stated best management practice for regular monitoring and reporting. Pardon me, have to back up. A note here so people are aware, understanding that the term annual monitoring is being introduced. This is as an inventory specialist and an expert in inventorying and assessing stream crossings, this is going to be a very difficult task to complete, and this will be coming as a documented best management practice soon. So annual inspections of watersheds in high-risk watersheds is going to become required. So plan your resources wisely and accordingly. You can still fix the problem if you work with your people and your construction resources. So lastly, you have to check on your construction works. You have to conduct maintenance as needed and report on it. Small fixes will prevent major failures, as all crossings really are temporary. So ask the regulators about the ecology of the stream and the site. Is the passage restored and are fish using the new channel? An ecological response is going to take years, and it'll be the final say in whether the work was successful. This will be the regulator's job, as it's a landscape level application, and it will drive spatial restoration objectives that evolves over time. Meaning, as we fix one prioritized watershed which has been broken, we need to move on to the next, and so on and so on. So that's really all I have, Daniel. Thanks for having me, and thanks to the AWC3 and all the other presenters in this series that helped put this together. Appreciate it.
Thanks, Bruce. That was a great presentation. So yeah, we'll go on to the Q&A portion now. I don't really see any questions that have come in just yet. So to give everyone a couple of minutes to get their questions in, I'll put up a quick poll. It's something that we've been doing at every one of our presentations, just to find out where everybody's coming from. So it's just to find out what your affiliation is. So I'll launch that. I'll give everybody about a minute to answer those. I guess while everybody's answering, I'll let you know that a recording of the presentation will be distributed to everybody who marked themselves as registered for the presentation. So your email has been submitted to GoToWebinar, so we'll send out the, oh, someone's saying the quick poll is not working. We've heard that from a few people now that it doesn't work. Not totally sure how it works, to be honest, because I've only been seeing it from this side. So I apologize if you're not able to get your response in. Yeah, sorry, to finish my point from earlier, we will be distributing the recording of this presentation and a transcript of the Q&A portion shortly after the presentation is done. So if you do have any questions, we'll try to get to them today. If we run out of time, then we will hopefully be able to we'll be able to incorporate that into the Q&A transcript, and we'll get that answer in there once it's distributed to everybody. So I'll just close this poll. Thank you to everybody who answered. We'll jump into the Q&A. Sorry, just sorting through all the messages that have come in. So here's a question. Oh, and just a reminder that we do have Mike Hunka with us, who can also help answer some of these questions. So this question is, do you recommend putting the inlet of the pump and hose setup in a bucket?
Yeah, absolutely. Great point. What we actually do is take 5-gallon buckets and we drill big 4 and 6-inch holes, and we wrap that bucket in half-inch mesh as well. So that's great, because if something is headed towards your inlet, your intake, it's pretty hard to catch. Good point.
All right, great, thanks.
Sorry, Daniel, can you just repeat that quick? Sorry, I didn't catch that question.
Oh, yeah, sure. So someone was asking, do you recommend putting the inlet of the pump and hose setup in a bucket?
Yeah, so I guess just to be clear, that definitely is acceptable as long as you are within an isolated area that has been all fish rescue's been conducted, because otherwise you're going to need an appropriately sized fish screen on the end of that intake. So that will work as long as you've established a fish-free area where your actual pump is sitting. And then, yes, you can put that inside a bucket. That's not an issue. But otherwise, you need to use an approved fish screen on the end of your intake.
All right, thanks, Mike. So the next question is, where can you access the priority watersheds map shown at the beginning of the talk?
Mike, I'll let you answer that one.
That's a good question. So the priority area map that was shown was drawn up specifically for the roadway watercourse crossing directive. I'll have to look to see if that's publicly available. That may be internal information only.
When we reply to these questions, I'll include a link to that question number 2 there.
Yeah, I think that one may have come from an information package that is publicly available online. Yeah, so we can provide a link to that. So next question, regarding drones, would the drones be programmed by a service provider or by the biologist engineer on site?
That totally depends on the scenario you're working within. It actually, in my working circle, our construction managers often fly them. Internally, we fly them, and external biologists. Just lots of people are starting to fly these now. Small drones don't need any special certification, and we're talking the really, really small drones. Once you get into a commercial drone, you get into a whole different set of regulations that you need to abide by. For instance, the smallest DJI Mavic Lite or whatnot is built specifically that it requires no permitting. I hope that answers the question. And in terms of programming, there's no programming if you're just capturing simple photo of the site, 1, 2, or 3. But if you're actually capturing, you wish to develop a 3-dimensional point cloud of the site, then you would want to program the drone so it flies a specific array, capturing the right amount of overlap, which is around, I think Ian mentioned 85% overlap in your photos. In that case, yes, you want to program it, and you would require the software to do so. And somebody who knows how.
All right, thanks, Bruce. I see another message that popped up from Victor who asked the question saying, yes, that does answer the question. So thank you. The next question here. Some of the placed trees in your presentations showed a full blockage of water with it topping over. With it being placed manually, what do you think of it being an unnatural barrier to fish passage?
I think we're talking about the tree bowl. So I'm pretty sure, if I understand this correctly, on some of the projects, we applied for temporary field authorization for entire tree harvest. So not like in forestry where a buncher clips a tree off, but we pulled an entire tree out, stump and all. And we wanted to use those tree stumps as channel roughness. And we actually, we cut the stumps off at 3 meters and we pushed the stumps into the bank, the bole of the tree into the bank with the root wad facing upstream. So is it a blockage? No, because it's an open flowing channel. It's roughness and it's adding a massive amount of nutrients and whatnot. So I don't think there's anything unnatural about putting a tree into a creek. I think what's unnatural is a crossing location having no woody debris. And that this is something that we really need to start incorporating. I think I answered that, not sure.
All right, thanks, Bruce. So the next question, are there any RAPs, so restricted activity periods, based on non-sport species? Maybe Mike can answer that.
That's a good question. Yeah. So all of the restricted activity periods are based on sensitive species life stages, right? So they are based on sport fish species. Normally, if you don't have sport fish species within an actual creek, you'll usually see no restricted activity periods, but that's not applicable in all situations. It depends also where those creeks are connected to. So in most cases, I mean, in all cases, yes, they're based on sensitive life stages of sport fish species. I guess just to add to that, though, that covers the restricted activity periods of sport fish species will cover most sensitive stages of forage fish as well.
All right, thanks, Mike. Next question here. Can you elaborate on considerations for release locations for salvaged fish?
Yeah. Your stated best management practice is to put them above the isolated work zone, primarily because fish swim upstream, and secondarily because you're dewatering the creek at times. So there could be, and you are going to be putting some sediment into the creek. So ideally, you always want to be putting them upstream of the salvage works. In the case when you're working late in the season, if you're dewatering, say a culvert with a large plunge pool, you're going to have fish that have chosen that pool to overwinter. You need to find a location similar to that to put them in. It's not ideal, and you're going to run into barriers there with the regulators, and rightfully so, because you're displacing fish, and that's tricky and time consuming. So it comes to timing of the works there.
Yeah, and that's an excellent point, Bruce. It is season specific. So if you are doing any sort of salvage works in periods of low flows in the fall and or winter, you definitely need to be relocating those fish back into overwintering habitat. But you're right, in most seasons, yes, you want to release them upstream in case your project has some issue that arises where you have a release of sediment. Ideally, those fish are released above your work area.
All right, thanks. So do you monitor success of willow staking post work? Does willow staking work if cutting willows after they have leafed out?
Yeah, we'd like to monitor all our sites if we're able to. So, but with willow staking, they are an amazing little creature. They'll take anywhere. So after leaf out, absolutely. I think the key to success is how you handle them. So that's why I mentioned start early. As soon as you're on site, and if people are clearing, there's always willows at a creek crossing site. So have a pair of large shears, like the big two-armed, the big beasts, and you want to be cutting these at an angle and soak them for a long time. So tie a bunch into a big bundle and soak them in the creek for as long as you can. And when you pound them into the ground, I recommend a big metal pole and like a big giant pry bar or even a crowbar, and two-person job. Somebody walks along and puts a 50, 60 or 70 centimeter big hole into the ground, and you put the plug down into that. So don't put these things, don't think of them as a forestry seedling. You want them as much in the ground as they are out of the ground. And they always take.
All right, thanks, Bruce. So this next question, first off, they're saying it was a great presentation, so thanks for that, Bruce. With respect to future regular scheduled watershed crossing monitoring requirements that you mentioned at the end, what sort of training or certification or knowledge development is required? And do you foresee or are you aware of any of those being associated with this phase?
It's kind of a regulator question, Mike. Do you want to?
Yeah, I can take that. So, I mean, there is third-party training centers that can provide training on doing watercourse crossing inspections. That being said, there is the option to train in-house staff to do these inspections. And, you'd obviously want to have somebody that has knowledge and experience in doing watercourse crossing assessments, providing that training to your staff. But there's no specific designation that you might need that dictates who can and cannot do watercourse crossing inspections. Ideally, it is a QACE or a professional biologist that's doing this. However, that's not a requirement in any policy or legislation. I guess the caveat there is that if you have people that are not appropriately trained in doing watercourse crossing inspections and they're not collecting data appropriately and they're misrepresenting potentially what those crossing inspections, what the results should be from somebody that is qualified, if that's not accurate and it's not consistent, then you do run the risk of running into issues with audits that will be happening by regulatory agencies. And so that would be my only caveat there, is that you definitely want to have somebody that is qualified, that is training staff to do this.
Thanks, Mike. This next question is also kind of regulatory, is about a regulatory subject, so maybe I'll ask it to you again, Mike. But this is asking, can you give a quick summary of the new regulation changes coming in the MSSC? And is there an approximate date that the new MSSC will be released?
It's a good question. So I did cover that in my presentation that I gave earlier in the middle of May. So that you could also reference that as well if you'd like to listen into that. Just a quick overview, the changes coming to the MSSCs are going to be the requirement to install type 1 or 2, so either bridges or arch type culverts in all of the priority watersheds that are identified, which will be provided with the updated MSSCs, so what they're calling high-risk watersheds. So in any of those watersheds, replacements and or new installations will have to be either class 1 or 2 crossings. There's that change. There's the requirement to conduct annual inspections of your watercourse crossings in those watersheds, again, identified as the high-risk watersheds that are going to be provided on the spatial layer. There's the requirement to decontaminate your equipment prior to works. What other big ones are there? Those are the main ones off the top of my head. And then in regards to the release date, I don't have any confirmation on a release date. However, I can say that there is cross-agency discussions going on to ensure alignment with this. So the draft is already in existence. It's already being circulated amongst the various regulatory bodies. So I would say probably within the calendar year, you could expect to see that released. However, I can't say with any certainty.
All right, thanks, Mike. So the next question, is it okay to combine both provincial and federal, so the DFO, best management practices, or just stick with one?
I'll take that. Do what's best. Absolutely combine. And honestly, if you know a best management practice that trumps what is going on here, I would employ that too. I like to think that's what a professional is. These are tools in the toolbox to reach to create a product, and whatever we need to create that we use. So I always defer to what is the best. So combinations for sure.
Yeah, and I would agree with that, Bruce. I guess maybe just as a caveat there too, for everybody's information, provincial legislation and federal legislation, neither is overarching over the other. You have to comply with both. And so if like Bruce is saying, if one dictates that you must do certain mitigations that are above and beyond the other, then you still have to comply with both. So neither trumps the other.
All right, thanks. We are running out of time, so we'll maybe just get to one more question and then I'll wrap things up. So when willow staking after leaf out, do you still trim all the branches from the stakes?
Absolutely not. It's a production. When you get to this point of the restoration project, it is a production thing. So willows are and poplar are so incredible hardy when you plant them properly. And you can cut off a willow branch that has multiple laterals on it and make a hole with your metal rod and shove the whole thing down, branches and all, and it'll take.
All right, great. So yeah, I'd like to thank today's presenter, Bruce Nielsen, as well as our panelist, Mike Hunka. Thank you to everybody who attended the webinar, and we hope that you join us for some of the other webinars in the next 4 weeks. Our next webinar in the series will be taking place next Tuesday, June 9th, where we'll have Owen Cook from AEP giving a presentation on current compliance and enforcement standards and guidelines. So if you enjoyed this webinar, I encourage you to look at the other webinars that we have scheduled as part of the series on our GoToWebinar page or on the awccc.ca website, and register for some of those other presentations. So thank you again, Bruce and Mike, for presenting today, and I hope to see everyone attending some of our future webinars. Stay safe and have a great day.
Thanks, Daniel.